Welcome to the first session of INF 154. So this session is going to be divided into 3 parts. So in the first part, we are going to focus on the basics of programming. And in the second part, we are going to focus on the graphical user interface, which is what we are using on Visual Studio Code for 154. Then in the third part, we are going to start coding. So in the first session, normally when I tutor people on campus, this session they consider it as a boring session, but later in INF 154 and in INF 164, they realize the importance of this basics. So we are going to start slowly. So we are going to start with the first session, which is your basics of programming. So I'm not going to go into the theory of programming, history of programming, and all of that. So I'm going to jump into variables. So I'm sure you've heard of variables from your lecture. So a variable, it's a memory location with a name and a type. By a type, we mean the data type that stores different values in each moment of program execution. So in summary, a variable is a memory location. A variable must have a name and a data type. So a variable must store different values at each moment of execution. Variables must be declared before used. So we are going to understand these like steps. So before we can go into further details, we are going to ask ourselves, how do we represent data in our memory? So how do we represent variables in our memory? You can think of a variable as a box that stores like a certain value. So that box has a name, has a data type, and stores a specific value. So that's how we visualize variables. This is the most important thing that you have to understand. Visualization, whether it's variables, whether it's objects, whether it's classes, whether it's arrays, you have to visualize these things. That's the thing that they don't teach. You have to understand. If you understand the visualization, then everything becomes easy. So you can think of a variable as a box where you put a value. That box has a name, then it has a data type. So we are going to, how do we declare a variable? So in your code, you are going to put the data type, then you put the variable name, or you can say data type variable name equals to a certain value. So in memory, this thing, data type variable name and value, it's like this. You have the data type, name, then value. You are going to understand what this means in a few seconds. So before we start with variables, let's consider the different data types you can use to store variables. So we will start with integers. So integers are whole numbers. They are used to store whole numbers. For example, you can have -1, you can have 10, you can have 12, you can have 10,000, any whole number. You can represent any whole number. So the general syntax for integers, you have this int, then name equals to value. So int is your data type, which represents integers. Then you have this name, which is your variable name. We usually call this an identifier. The name of the variable is an identifier. Then you can have equals to, then you put value, where value is a whole number. So as an example, I'm going to use this. So I'm not going to use Visual Studio Code for this session. So it's just theory. So I'm going to, for now, don't care about this other code. So focus on the code that I'm going to write in between these comments. So the code that I'm writing in between these comments. For now, we are not using Visual Studio Code. We will get to that. So I'm going to say int, then I can say number, then like this. So how do we represent this single line of code in memory? So we have this int number, then semicolon. Then how do we represent this? The int tells the compiler that we are using an integer. Number is an identifier, is the name of the variable. So in memory, we are going to have this int, which indicates the data type. Then we have this number, which is your variable name or the identifier. Then we have this box. Currently, we don't know the value that is being stored on this box. For example, if I try to print this, so to print something, you don't have to worry about this. So I'm going to try to print this number and see what's going to happen. So if I try to run this code, so use of an assigned local variable. So we didn't store any value, so it's empty. We don't know what's the value. So how do we assign a value to a variable? So you just use the name of the variable, then equals to 10. This line is going to store this 10 in this number. So in memory, we have this int, we have this number. Inside the box, we put what? We put 10 as the value. So now I can say, later I can say number equals to 10. I have something like this. Now let's try to run. At the end, my number is 10. So what if I want to change the value of number and put a different value? We can use that because this is a variable. The reason they are called variables is because they can vary. So you can change the contents. So let's say I want to change number to -15. So at the later stage, I can say, okay, now my number is equals to -15. Then I can try to run this again. Then I should get 15. How did that happen? So we had this 10. When I say number equals to -15, this is going to override whatever we had on that previous number. So we are going to throw away 10. We don't care where it goes. Then we put the new value, which is -15. So that's how integers work for now. We are going to cover mathematical operations later. So now we can move to another data type, which is your double or your float. So double or float stores decimal numbers, or in mathematics we call them real numbers. So it can be 10.5, -11.2, it can be a whole number 10, it can be 12.05. So the general syntax for these doubles, it's similar to integers. The difference is that you use double, then you put the name or the name of the variable, or you can just do it in one line. Double name equals to value, where double is your data type, name is the variable name or the identifier, then we have the value, which is your decimal number. So in simple terms, we have this double, then I can call this price. So if this line only in memory, it's going to be represented like this double price. Then I have my box, then I can maybe assign price to something. For example, I can say 10.5. So at the later stage, I can say, okay, my price equals to 10.5. So equals to, when I use equals to, I'm assigning a value to that specific variable. So I can say 10.5. Then now I can print the price. So don't worry about this console.write. It's used to print values to the screen, but we are not going to use this. We are going to use the graphical user interface. So focus on this code. I can even do this. So you have to focus on the code in between these comments. So double price, initially we don't know anything about price. When we say price equals to 10.5, we are storing that 10.5 into that specific box. If I run this, I'm going to get 10.5. Then if I check here, we have double, then price 10.5. Or I can do this in a single line. I can say double price equals to 10.5. Here we are declaring and assigning the variable at the same time. So if I run this, I'm going to get the same output, which is 10.5. So in memory, it's like that. At the later stage, I can change price to something else. Maybe price equals to 25. I can say price equals to 25, or it's 25. Then I can run this. Then at the end, I'm going to get this 25. How is this possible? Because we threw away that 10.5, then we put what? 25. Then I can repeat this by saying price equals to 25.6. It works the same way. We are going to throw away the 25 we have, then we put 25.6. Then you will notice now I'm just ignoring this double. So just for simplicity, I'm just ignoring this to put the double the way we did. So I just represent the variable with price in memory. So price stores 25. At the later stage, price stores 25.6. So now we can move to another type, which is Boolean. So these ones, they store true or false. So in C++ or digital circuits, this is known as a Boolean value. So it's where true represents, where 1 represents true, 0 represent false. So if you are doing computer engineering or electrical or electronic, you are going to deal with ones and zeros a lot, especially when you are writing your assembly code. So the general syntax is similar to that one of doubles. So you are going to have bool. It's what we use to represent booleans. The name equals to value. So where your bool is the data type, name is your identifier, value it's either true or false, nothing else. So example, we can declare variable called is valid. So because this is a Boolean variable, I can say bool then is valid. Then in memory, when I do this, I'm declaring the variable. So I didn't assign any value. In memory, I have this bool is valid, then I have an empty block. Then at the later stage, I can say is valid equals to true, like that. Then now when I check the code, I'm going to have this is valid equals to true. This true will be stored in that box. Then at the later stage, I'm going to say is valid equals to false. We are going to remove the true we have, then we are going to put that false. So we are going to have at the later stage, I can even print this is valid before. So is valid, I have this, I must get true. So it's true. Then at the later stage, I want to change this. So is valid equals to false. Then now I must get false because this is the latest update. Is going to override the recent update. Now we can move to the next section, which is characters. So characters, they store a single character. For example, symbols. You can store a hash, you can store a 0, you can store a 1, you can store a 2, semicolon, any single character. Basically, you can store 0 to 9, A up to Z, then capital letter A up to Z. You can store percentages, any single character. Then you can store what we call escape characters. So escape characters, it's a backward slash and a symbol. So these are special characters for a specific language, but you won't use them that much. The only character that you are going to use in most cases is this new line character, which is backward slash n. So let's see how characters work. So the syntax, then the other important point is that they are enclosed in single quotation marks. So the general syntax is this char, or you can call it char, whatever. Then name equals to value. Char is the data type that represents characters. Name is the identifier. Value is a single character or an escape character. So for example, let's say we are declaring a character, maybe car or char, whatever, maybe I can call this symbol. Then in memory it's going to be like this, where you have char, then you have this option, then you have an empty box. You don't know what the value is because you didn't assign this. Then now I can store something, maybe option equals to hash or hashtag, option equal, or symbol in this case, symbol equals to hash, or you can, let's call it option. So this option equals to hash. So you are going to have this option where you have option, then I can run this. I must get hash. Okay. Oh, you see, now I used double quotation marks instead of single quotation marks. So characters are single quotation marks. So now it printed this hash. Then I can remove this since we are not using this. So if I run again, I get this hash. So char option in memory, it's like an empty box because you didn't assign it to anything. Then in memory you just have an empty box. Then when you say option equals to, that's where you are that's when you are storing something to your char. Then at the later stage I can assign this option to an ampersand sign, or you call it an and sign. At the later stage I can say option equals to, then I can say and, then I can execute this. So at the end my option is this end. So the next data type is strings, which we are going to do, like we are going to deal with them in later sessions. So strings, they are used to store like a sequence of characters. So it stores a sequence or an array of characters, of one or more characters. In simple terms, strings stores text. So they are enclosed within double quotation marks. So the general syntax is string, then you just say name equals to value, where the value is the text, string is the data type, the name is the identifier. So as an example, you will have let's say string, then I can say name. Then how is this represented in memory? In memory you have string, name, then you have an empty box as usual because we didn't assign. Then let's say I'm trying to assign this, maybe name equals to, then I can say name equals to Vincent, then I can display this name. I can remove the option, this option. Then now I execute this. What am I going to get? I must get this name. Then how are strings represented in memory? So in memory, to represent a string is a sequence of characters. It's an array of characters. So it's multiple, it's sort of multiple characters combined together or stored within continuous memory locations. So V is going to be stored in position 0. So in programming, we start counting at 0. When you start coding, you are going to start at 0, then 1, 2, 3, then up to that specific number. So V is going to be stored in box 0. I is going to be stored in box I. N it's going in box 1. N is going to be stored in position 2. C is going to be stored in position 3, and so on until the end. What if I want to change the name at the later stage? And this is how we represent strings in memory. So name, then you put the arrow, then you just put those characters. Then how do we represent those strings? Or let's say I want to change the name later to maybe something John. Then I can say name equals to maybe John, like something like that. Then I can just execute this. So the latest update, it was this name equals to John. So now this thing is storing this John. So J is going to position 0, then the others just follow immediately after 0. It's 1, 2, 3 until we reach the end of that specific name. So we will cover strings later in another session. For now, just know that strings it's an array of characters, one or more characters. Then in later stages, we will see how we will cover like operations on strings, like concatenation, the addition of strings, and so on. Then the next part that we are going to do is identifiers. So identifiers, these are names of variables or objects or controls. For example, int num equals to 10, we know that num, it's your identifier. It's the name of the variable. So what are the rules for naming your variables, or what are the rules for identifiers? So the basic rules, we cannot just give random names to identifiers. We have to follow a specific convention. So they must contain, it can contain letters A up to Z, or capital letter A up to capital letter Z, and it can contain digits 0 up to 9, and they can contain what? Underscores. So they cannot start with a digit, cannot contain other symbols such as hash. These other symbols, they can start with a letter or underscore. Then for examples, I'll give you examples of valid identifiers. So let's say I'm writing a program where I'm getting like the name and surname of a user. So I can say, okay, for the name I can use name, or I can use first name. So first, then if I say name equals to, maybe I can get it from a txt, from a text box, txt name.text, but here we are not doing the graphical user interface. So let's say string, then first name equals to maybe whatever, something like that, or I can say Vincent, whatever, I can write anything. Then this is a valid identifier because yes, it contains letters A up to Z. It doesn't even though it doesn't contain underscores, digits, but it's a valid name because it contains letters. So do we have any other symbols? No. So this is valid because we don't have symbols So if I try to run this, it must be valid. Let me just update this first name. It must be valid because it's the name. This thing is, it's a valid identifier. What if I try to put and? This is a symbol. According to the rules, identifiers cannot contain symbols. So when I run this, I must get an error. Even if I put like any random symbol here, if I run this, I must get an error. This is not a valid identifier. So what you can use is an underscore, maybe to show that it's first name. This is valid because it's an underscore. So if I run this, it must be valid. The only issue is here, but it's valid. It's a valid identifier. Then another example, maybe double, maybe I can say price, the one we saw, equals to maybe 10.5. This is a valid identifier. If I say double, maybe I have another price 1 or price 2 equals to 20. This is a valid identifier because it contains letters, digits. Then I can have another one, double price, maybe underscore 3 equals to 10. This is valid because we have an underscore, or I can say double underscore price equals to maybe 200. This is valid because the rule says they can start with underscores, they can start with a letter, or an underscore can not contain other symbols. As long as it doesn't contain other symbols, then as long as it doesn't start with a digit, and yeah, I think as long as it follows these basic rules, it's a valid identifier. So we can't be wasting time on identifiers. These are some of the examples of valid identifiers. Price, num is valid, first name, pi, a, b, then underscore person, number of elements. These are valid. Then examples of invalid or invalid identifiers are price, where you put the character. Then here I have 1%, it starts with a digit, it's invalid. Then people, then I have this symbol, it's not valid. Then you can come with other examples from that specific rules. Then we have this assignment operator. So the assignment operator is the equal sign. The equal sign is called an assignment operator in programming. So the equal sign takes two values. So values on your left and values on your right. We call these values operands. So on the left we have your variable, which is an operand. On your right we have another operand. So for your left, you can only have one operand. You cannot have more than one operand on your left. Then on your right, you can have expressions, mathematical expressions, which we are going to cover. You can have like values. You can have other variables, which we are going to cover. Then variables on the right of the assignment operator are not affected. They don't change. We store the value of the expression or variable on the right to the variable on the left. So this is my crazy example. Let's say you have box equals to shoes. So this box, it's your like physical box. Then when you say equals to shoes, it's like you're storing shoes inside the box. So these shoes are not affected. The box was empty, then you put something, so the space of the box decreased, so it was affected, but the shoes, they are not affected. So that's some crazy example. Then examples, if I say int a, so in memory we know that it's going to be an empty box. Then a equals to 10. Then in memory we have A. Now we are storing 10. So A is there, then we are storing 10. 10 is not affected. 10 doesn't change. You can't say now 10 is 11. You didn't change the 10. 10 remains 10. But A is affected because now it's storing A in that specific box. Then another example, we have this int B equals to 10. Then in memory we know that it's going to be B, then it's storing 10. Then int A equals to 20. So in memory you have this A which is storing 20. So when you say A equals to B, so A is in the left, it's the one that is going to be affected. B is not going to be affected because it's on the right, so B will remain as 10. But A equals to B, so we are just storing the value which was at B, which is 10, to A. So we throw away the 20 we had, we are storing the value of B to A. So that's what we mean by assignment. You see, A equals to 10 plus B. Another example is A equals to 10 plus B. So 10 is not affected. Then when we see B, we are just going to the box, fetch the 10 we stored. So it's 10 plus 10. So the result will be 20. And this 20 is going to be saved where? At A. So the 10 was not affected and the 10 from B was not affected. So B is going to remain the same. Then another important property is that operands must be of the same type. If not, you have to use convert to. So you cannot assign an integer to a string, you cannot assign a double to a string, and so on. You have to convert. Every time when you are using an equal sign, ask yourself, what's the data type of the operand on the left? What's the data type of the operand on my right? For example, if you say int number, so int is an integer, num is it's the name of the variable, then equals to 10. Although 10, you can view 10 as an integer, but when we put it inside double quotation marks, it's a string. So this is not a valid assignment. Cannot assign a string to an int. You are going to get that type of error. So then how do we fix this? What if we took, let's say, price from a text box and we want to store it in a double or in an integer? That's where we use the convert.to method. So convert.to int 32, then you put the value. This converts value to an integer. So value can be a double or a string. Then convert.to double, then value converts value to double. So it converts the value to double. Then convert.to, then string value converts the value to a string. So let's try to use that, the convert to. So I can say, okay, int price equals to 10. So in memory we have this price, then in the box we have what? 10. That's all. Then at the later stage I'm saying price equals to maybe 20, or price equals to, maybe I want to change it. Let's say I have an input from a text box, for example, maybe string input equals to maybe 200, whatever. I want to say price equals to input. So let's see what's going to happen if we run this. So let me remove this, then I can run this. So you see it says cannot implicitly convert type string to an integer. So this is a string. You have to ask yourself, your left operand, it's an integer. Price, it's an integer. Then input, it's a string. So you know that something is wrong. What do you have to do? You are storing to what? To an integer. So you have to convert this to what? Int 32. So I can say convert, then 2, then int 32, then we just store this. Let's try to run this now and see what's going to happen. Convert. So it was a typo. Let me remove this and see what's going to happen. Now it's working. I can even print, let's say console.write, console.write line, then I write the price, then at the end I must get 200 because this was converted to an integer. The input was converted to an integer and it was stored to price. So if your data types are not the same, every time you use an equal sign, this is what I always emphasize when I'm teaching people. Every time you use an equal sign, you have to ask yourself, what are the data types on the left and on the right? Even if I want to do something like this, maybe int sum equals to price plus input, this is still not valid because I have integer which is valid, price integer valid, but this one is a string, so I have to convert to a string. If I run this, I'm going to get an error, so I have to use what? Convert to, then int 32, because I'm converting to integer or to an integer. If I execute this, I'm going to get a valid input thing. Oh, here I printed price. Let's print sum. So I must get we are going to cover these mathematical operations at the later stage. So that's how it works. The basics, these are the basics. So in the second session, we are going to dive deep into text boxes. Graphical user interfaces, which include your text boxes, rich text boxes, buttons. We are going to focus on how to take data from buttons, from those inputs, the text box, rich text box, numeric up, down, and use them in your code. We are going to cover assignment operators. We are going to cover mathematical operators like your sum, like division, powers, everything that's related to mathematical operators and graphical user interface. So in the next session, we are going to start building these applications using your Microsoft Visual Studio Code. Then in the third session, that's where we are going to focus on problem solving. So let me just show you like maybe a simple code. Maybe if you know one language, it's easier to like go to other, like to study other languages. So I'm going to open something like this, subl skip list.java, something like this. So if I open this code, you can see that you still have those integers, you still have those int, boolean, which are bools in C#. But what I'm trying to emphasize is that once you know like one code, you can transition from one language to another language. You can like build these complex. This is artificial intelligence, by the way. So here we were supposed to build like a simple game for our practical. Like we were supposed to build a board that will play rock paper scissors with another machine. So that's not important, but what I'm emphasizing is that once you master the basics, it's easier to move to more advanced concepts, because even when you build a house, if the foundation is not strong, you are going to, like, the house is going to fall when difficult times comes. So the foundation must be strong enough. So you have to make sure that you understand we are not here to just pass, cram, pass and forget. We are not here to do that. We are here to understand and apply what we learned to solve real life problems. So we are going to cover, in our sessions, we are going to cover like many problems. So my goal is not to teach you and just get a distinction. That's not my goal. It's either for you to understand and not get a distinction, which is almost impossible, but understand. The main goal is for you guys to understand. So yeah, I think for this session we will end here. Then I'll see you on the upcoming sessions.